So today's webinar topic is about utilizing AutoWiz for story of data. So as a data scientist, we all know that EDA is very important step in data analysis, right? So how visualization helps us. So it helps us in finding the trend or pattern in the data, right? And it helps us in many ways, like for feature selection or feature engineering. So basically, EDA is helps us in finding the correlation between the features or how the variables are. How what is the impact of the variables on the target variable. So many things that we get from EDA where we try to understand about the features, right? So we all know how visualization plays an important role in data analysis. So you would be having Matplotlib, Seaborn library. They are the basic Python libraries, right? So where you can use them for basic analysis, right? So we also do have automated EDA libraries, which makes our task very easy. So it's more efficient. So one such library we are going to see today, which is AutoWiz. So we have Nishit here who is going to present this webinar. So at any point of time, if you have any doubts, you can put it on chat. So we will go through it and we can have discussion about all the questions at the end of the webinar. Okay. So over to you, Nishit.
Yeah, thank you, Kalpana. Uh, good morning, everyone. Rather, good afternoon. We'll get started with the webinar in a while. Okay. I hope my screen is visible. First of all, very warm afternoon to everyone. Now, as Kalpana already said, EDA, the story of data, is very important if you want to know what the data is actually doing or what that particular model is actually training on or how certain features are correlated to each other. Now we have very conventional libraries in Python like Matplotlib, Seaborn, etc., which we have been using conventionally to plot bar charts, box plots, distribution plots, scatter plots, heat maps, etc. But it's a very tedious task, plotting every single variable against another variable, and then one easy way is to loop through it. But again, you have to initiate loops for every single graph again and for every single variable. Now, won't it be amazing if we have certain library or libraries that help us in automating this entire task, so that we won't need any other library for our EDA, rather use these libraries and get to know how our features are correlated to each other and stuff like that. Excuse me. So we have two libraries, rather not two, a lot of libraries. We have SuiteWiz, AutoWiz, etc. Now, this webinar will focus on AutoWiz and how we using AutoWiz to visualize our EDA and how to go about our exploratory data analysis. Now, this EDA and in the end will help us create a better machine learning model or a better data visualization or better analytics, whatever is the goal of our entire project. So if you're working on a notebook environment, say Jupyter or maybe Jupyter Notebook or Google Colab, you have to install AutoWiz first in this way, like the first cell that you have. For Google Colab, it's pip install. And if I'm not wrong, for Jupyter, it will be exclamation pip install AutoWiz. So after you're done with installing the AutoWiz, we have to pass this matplotlib inline. Now, what this matplotlib inline does is, when you have graphs, your matplotlib inline is essential to display your charts, because if your charts are not inline, it won't be visible in your Jupyter Notebook or your Google Colab, because after 0.14 version of the notebooks, Matplotlib inline has become essential to visualize your charts. Now, after you've done installing your AutoWiz and after you're done passing the Matplotlib inline command, you need to import AutoWiz class. Now, AutoWiz class is nothing but a parameter or a function where you pass in a CSV format of your data set, which in turn visualizes your entire data set. So first you declare a AutoVis class. You can name it anything. I have named it here as AV. AV is equal to AutoVis class. You can name it anything. Now, after you named your AV AutoVis class, we will first look at today what data set that we're taking. Now, before we jump into AutoVis and how we're plotting our charts, I'll tell you about the data set that we have taken. So the data set that we have taken today is Shark Tank India data set. Now, Shark Tank, as you all know, was a startup competition kind of thing where inventors or entrepreneurs pitch their ideas to a panel of sharks or judges. They're known as sharks, and these sharks are well established moguls in their particular departments, and they have a lot of uh, like equity or cash to give off or invest in these startups. So Shark Tank India is basically like working on a simple concept. A person goes, they ask for an equity. Equity is nothing but a percentage of, let's say, your company in return for certain amount of money. So you can ask for a 5% equity or a 10% equity in exchange for $1 million as a loan, or $2 million, or 10 crores rupees, or something like that. And you give off 5% of your company or 10% of your company to that particular shark. So any profit you have over the period of time on any product that a company sells, 10% of that belongs to your shark that invested, that gave you the money and took this certain amount of equity from you. So this data set that you've taken over here consists of the episode numbers. In total, we had, I guess, 35 episodes. And in total, we had 117 pitches. Now, in 117 pitches, we had a lot of brand names. These are the brand names: Blue Pine Industries, Boo Scooters, Heart Up My Sleeves, etc. And then we have their ideas. Then the deal. Here, deal is that if they got a deal, or if they took a deal, or they didn't take a deal. So now the next features are pitcher ask amount. Pitcher is now no one but the person who is pitching the idea. So pitcher ask amount, let's say they've asked for 50, let's say it can be 50 lakhs, and ask equity is 5%. So they are asking for 50 lakhs in exchange of 5% of their company. And ask valuation is nothing but the entire valuation of the company. And deal amount is the deal amount they've received, and deal equity is nothing but the final deal equity that they have agreed on. Now, Ashneer deal, Anupam deal, Aman deal, these are nothing but which all sharks wanted to give a deal to these companies, and how many total sharks invested in these companies. And amount per shark is nothing but the total amount invested divided by the total number of sharks that invested in that particular company. And finally, we have equity per shark. Okay, just a second. Okay, yeah. So after that, these are all the features that we have. Now, after we have these features, now you must be seeing there are 117 rows and 28 columns. Now, plotting 28 columns is a very, very, very big task. Now, you can't plot plotting 28 columns with respect to another column is like plotting 28 factorial graphs. 28 factorial graphs of each type: bar chart, plot chart, distribution, or scatter plot, or anything. So you can't plot that many charts, and most of the charts won't be important as well. So let's say brand name versus idea. It's not a chart that we require, right? Now we need a smart way to plot our charts so that like only the required features are taken in and the required features are plotted, but not the unrequired features that we don't need, because we don't need brand name versus idea. That won't give us any insight into our data set, isn't it? So we need just the features that are helpful in our EDA and in our final model preparation. Okay. So after we declare our AV, now we will here take av.autovis and pass our data set as a CSV format. Now, mind you, you might pass on your data frame over here, But if you pass your data frame, it won't identify your data set. Here you have to pass your data set as a CSV format. Every time, this is the only thing that you remember when you're dealing with AutoVis. When you're passing on your data set, you have to pass that data set in a CSV format. Now, if you pass it into a CSV format, then it will detect your data and then plot it. And if you're like worried that if you have your data set in a data frame and not in a CSV format, you can just use this. There's a command called df to CSV, if I'm not wrong, to CSV or something like that. You can pass that command and pass in your data frame. It will convert your data frame into a CSV format, and then you can pass that CSV format into your AutoVis class. Now we'll come to the most important part of this presentation, which is the auto visualization of all our parameters or our features. Here it is showing classifying variables in dataset, 28 predictors classified. There are total 28 columns, and it has detected all the 28 predictors. 4 variables removed since they were ID or low information variable. Now, if you can look into it, these 4 variables are very easy to identify. Brand name, idea, this index number, and some other parameter, which the algorithm thought that they were very low data or low information variables, or they were ID variables, which means they're not numerical in nature or contributing to the model. So it removed them. So 4 variables removed, and now it will do its classification on 24 predictors. Okay. Now total number of scatter plots. First it plots scatter plots. Okay. We'll look into this just a second. Okay, yeah. So here we have scatter plots of one variable plotted against another variable. Okay, here we have picture ask amount against ask equity. Then we have picture ask amount against ask valuation. Then we have picture ask amount against deal amount. Then we have picture ask amount against deal equity, and so on and so on. We have our scatter plots which show us what this picture ask amount is changing with respect to equity per shark. Okay. Now picture ask amount versus any other amount per shark deal valuation isn't giving us much anomalies over here. But now if we look at ask equity or ask versus ask valuation, now we can see our scatter plot is finally looking like a scatter plot, isn't it? It is showing us how much the contestants asked for equity and how much was the ask valuation, like the valuation of the company. Here we can see, we can spot outliers as well in the scatter plots. What will be the outlier in this ask valuation, ask equity? Here, as you can see, someone valued his company at 120K, 120,000, let's say 120,000 crores or lakhs, whatever the parameter is. And they asked for an equity of 25%, which is a quarter of their company. So this is an outlier. This contestant was one of the most different ones from all the pitches that these judges received on Shark Tank. Similarly, we have ask equity, deal amount versus deal amount, ask equity versus stuff like other parameters. So these are the scatter plots. Okay. After we are done with the scatter plots, we'll come with distribution plot, box plots, and probability plots. Okay. Now here it gets very interesting. Distribution plot is nothing but very easy. We must have seen in our primary maths and stuff. We have distribution of a certain variable. Let's say we have 80 of certain thing and 30 of certain things, and then 15 of certain things. How we distribute it in a plot. So we use bars and lines and show how many numbers of a particular stuff we have. So this is a ask valuation distribution plot. Now distribution plot is fairly easy to understand. Just a second. Yeah, fairly easy to understand. Now after distribution plot, we have box plot. Now box plots are very important to identify outliers and if your data set is normalized. Now, a normalized data set will have its box plots centered around its normal axis and outliers towards the left or the right. This parameter, picture ask amounts box plot, is not a normalized data series that we have. Similarly, ask valuation box plot is not normalized. Deal valuation is not normalized. Amount per shark is not normalized, but we have outliers in amount per shark. Here we can identify our outliers. And outliers are very, very, very important when you're creating a machine learning model, because you need to identify your outliers. All right. Now, so this is the story of box plots. After we have gotten box plots of our data set, we can also look at our probability plots. Now, skewness, like skewness is nothing but how much towards left or right our data set is tending from the normal. So if a skewness, we have a highly positive skewness, like very, very greater than zero, then it's probably not normalized and tending towards the right side or the positive side. And if we have a skewness tending towards zero, it is normalized. And if we have a skewness tending towards the negative side, then we have a skewness, we have a data set that is tending towards the right side, or it's not normalized. Okay. So this is where, like, box plot is used for identifying the outliers, and here probability plots and skewness you can use to identify if the data set that you're taking is normalized or not. So here skewness is decreasing 8.4, 3.6, 1.5. As you can see, skewness 1.5, it is looking more normalized, more Gaussian. Gaussian means if you pass on axis here and take on like a mirror version of this graph, it will almost replicate the left and right side of its graph. Okay, if you take an axis through the middle of it. Now, if you have a skewness of 0.8, it's almost zero. It is highly normalized. This deal amount uh, criteria of our data set. Okay, so this is our probability plot. Again, the skewness is increasing 3.7, 2.1, stuff like that. Next, we have distribution of total sharks invested. So we are taking only the top 15 categories over here. After like in the top 15 categories, it is showing how much like total sharks, how much deals, or how many deals these sharks invested in, and only the top 15 categories in which they invested in are shown in this graph. Then we have Violin plots. Okay, Violin plots is also very intuitive to identify outliers. Then we have one of the most interesting part of data visualization, which is heat map, a correlation heat map. Now, a correlation heat map is very, very, very important when you are trying to eliminate certain variables which are highly correlated to each other. Let's say we have a data set with our target variable as C and two features as A and B. Now, if A and B are highly correlated, let's say A equals 1 and B equals 2. And when A equals 2, B equals 4. And when A equals 3, B equals 6. So you can see a pattern, like B is always 2 times of A. So it is highly correlated. Now, you don't want to burden your machine learning model by taking both of these variables into consideration, because they both are basically increasing or decreasing in a similar manner and are correlated to each other, and will have a similar correlation factor with the target variable, that is our C. So you only need to take either A or either B. Now, here we eliminate, after we check out this correlation heat map, we eliminate features which are highly correlated to each other. Let's say we have features with correlation factors as minus 0.99 or plus 0.99. It can be, the correlation factor can range from -1 to 1. If it's -1 or 1, then both these parameters are highly correlated. So you can eliminate one of the parameters. Okay. So this is used for elimination of your features. Then we have, just a second. Then we have our bar plots. This is very easy to interpret. This can be used just to provide insights into the data set, not essentially required for your ML model, but this can be used to provide insights. Let's say you want to provide analytics for a certain data set, then you can use these charts. Average deal amount by episode number, average ask valuation by episode number, and stuff like that. And then we have average pitcher ask amount by total sharks, average deal amount by total sharks, and stuff like that. You'll have average deal valuation by deal. Now, all these parameters are plotted to show like how much was the average deal amount or how much was the average ask valuation. So here the average ask valuation 0 and 1. You must be noticing what is 0 and 1. 0 means the deal was declined by the pitcher, and 1 means the deal was accepted. So if the deal was declined, you can see that means the average ask valuation was very high, which is very common. Let's say I'm going and asking you 5,000, and one person is going and asking you 2,000. You'll be more inclined to give 2,000 rather than 5,000. So 5,001 has 0, which means the ask valuation was too high and the deal was declined here in this purple one. And here, as you can see, when we have our ask valuation is less than almost like 3,000, some 2,100 or 2,200, the deal was accepted by the sharks. Similarly, this is how you get insights from these graphs, and you can like note it down or maybe put it in your IPyMB notebook that these are the insights from the data set. Okay, then we have average deal equity, average deal valuation divided by the judges. Now we have 20 into 2, 20, we are taking top 20 episodes of each shark. We have our sharks, Vashni, Grover, Piyush, and Aman, and all. We are taking their top 20 valuation, top 20 average pitcher ask, average ask equity of all the judges, and top 20 of each of them, and plotting them to get insights. So this top 20 has been chosen by Autoviz. This top 20 has been chosen automatically by Autoviz. We have not passed any single parameter into Autoviz. Autoviz is a very smart and capable algorithm, and it understands how many we need, and how much our processor can handle, and how much this Colab environment can handle, how many graphs it can plot. So all this is taken into consideration by the Autoviz algorithm, and then the graphs are plotted. So we have our like average deal amount, average equity per shark based on all the judges, and we have 20 of each judges graphs. So this can also be used to interpret how the data is behaving according to each other. And after we are done with all of this, okay, we have a lot of graphs. So yeah, here you can see time to run AutoViz was 43 seconds. You just passed one single line into your Colab environment, and in 43 seconds, it gave you the entire EDA story of what you would have taken ages to find out between certain features or certain target variables, etc. So you now have like all the charts that you needed automatically presented before you within 43 seconds just by passing one line. So this is how AutoViz works, and this is how AutoViz helps in easing out our task in the journey of EDA and visualization, and eliminating features or keeping certain features. And this is how it helps us in building our final goal, building onto our final goal, that is a ML model, or maybe analytics model, or maybe data visualization, to get analytics out of it. So yeah, this was it from my side. If you have any questions, you can ask me.
Thank you, Nishit. So, any doubts? You can go ahead now.
Welcome, Soumya. Basavaraj, you have to type your uh, question in the chat box. Participants won't be able to speak anything.
Prasad, you can use it whenever you want. See, whenever you're going to, you know, perform EDA, you can use this automated EDA library.
Okay. See, Basavaraja, okay. See, when you're creating, like when you're getting correlation factors of two features, let's say feature A and feature B, when you have a very highly positive correlation factor, that means they're highly correlated, somewhere around 0.9 or 0.99. If you're also getting highly negative correlation factor, let's say minus 0.99 or minus 0.95, then also you can eliminate those factors, because then also they are highly correlated. Because uh, when you have a positive correlation, that means when your feature A is increasing in value, your feature B is also similarly increasing in value. And when you have your feature, let's say feature A and feature B, uh, uh, when one feature is increasing, highly increasing in value, and at the similar rate your feature B is decreasing, then you'll have a negative correlation factor, a high negative correlation, that is minus 0.99 or minus 0.95. In both the cases, both the features are highly correlated to each other. So you can just take one feature rather than two features. I mean, you can take both the features, but it will be like a burden to your ML model. If you want to make it faster, you can just take one feature and remove the other one. Okay. If you have a correlation factor of 0.001 between two features, then both the factors are not at all correlated to each other, or minus 0.01, which is less than 0, then you have to take both the features into consideration if you're training your ML model.
Nikita, both are automated EDA libraries, where SweetWiz you can use for univariate analysis, and AutoWiz you can use for bivariate and multivariate analysis. You have other automated EDA libraries also, so you can explore on that.
I'm sorry, what is the name error? Can you be more specific?
Soumya Darshan, if you can show that error, like what exactly you're getting, would be fine. Okay, for any doubts which you have any specific doubt where you wanted to share to us, you can drop a mail. Okay, we will look into it. So apart from that, any other doubts here? Okay, hope we have taken all the questions. And I hope this webinar was useful for you. So we want you to try this library for any data set, and check if you can work. Okay, and if you're able to get the insights. So any other doubts? So we suggest you to try with other libraries as well. So try to explore more and try to use all that. So if you have no questions, we can end the session here. All right. Thank you so much, Nishit, for your wonderful session. I hope this will be very helpful for everyone who have joined. So let's meet one more time for with some important topic which would be very useful for you. So that's it. So we'll see again then. Thank you
Sure.
all.
Thank you, everyone.